Hi there. In this tutorial, we're going to be looking at still finding vertical and horizontal asymptotes. But now we're going to look at how holes can be involved in a function. And we're going to continue finding intercepts and graphing these rational functions. So for this particular function, h of x, you might notice that both the top and the bottom can be factored into something, into its factors. So we have the top x squared minus 9. Remember, that's a difference of squares. So we can write h of x as on the top x plus 3 times x minus 3. And then on the bottom, we have a trinomial that we can factor using our AC method. And we need two numbers that multiply to -6 and add together to -1. It appears that those would be -3 and +2. So we'll write that out as x minus 3 and x plus 2. Now, in our graph, or in our function, you should notice that the x minus 3 on the numerator can cancel out with the x minus 3 in the denominator. And we can simplify our function even further to x plus 3 over x minus 2, or x plus 2. So then this is going to help us find our vertical and horizontal asymptotes and our intercepts, because if you remember, our vertical asymptotes are going to occur wherever the denominator is equal to 0, because our function cannot exist at that point. So we have x plus 2 equal to 0. So x cannot equal -2, or else it makes the denominator 0. So we have a vertical asymptote at x equals -2. So then for our horizontal asymptote, remember, we have to compare the uh, degree of the numerator with the denominator. And in this case, they're the same. So what that means is you have a horizontal asymptote that is the fraction of the first term in the numerator, in other words, the term of the highest degree, over the term of highest degree in the denominator. You're looking at the coefficients of each of those. So for my horizontal asymptote, my my x term on top has a coefficient of 1, and my x term on the bottom has a coefficient of 1. So I'm going to have a horizontal asymptote at y is equal to that fraction, which ends up simply being 1. So then the next thing I want to look at is intercepts. So, and we'll talk about holes in a second, but my intercepts for my x-intercept, that's going to occur where h of x is equal to 0. So that's essentially where the numerator is going to be equal to 0. So let's figure that out real quick. X plus 3 has to be 0. So it's where x equals -3. Um, so I have an x-intercept with an x value of -3. We can plug that in. H of -3 is 0, which obviously we just defined that. And then the y-intercept is going to be where my x is equal to 0, and that simply ends up being 0 plus 3 over 0 plus 2. So we have a y-intercept at the point 0, 3/2. All right, so I've copied in the graph of this function, and we can quickly confirm that everything we have here is correct. Vertical asymptote at x equals -2, and a horizontal asymptote at y equals 1. And then our graph should cross the x-intercept at -3, which it does, and cross the y-intercept at 3/2, which it does. So the last thing that we want to do, other than graphing it and stating the domain, is we want to figure out where the holes of the graph are. And if you remember way back in chapter 0, I believe it was, we talked about those removable discontinuities. Well, we have one right here where we removed this x minus 3 over x minus 3. If we would have kept that x minus 3 on the bottom, we would have found that our graph is also not continuous at x equals 3, because that factor also would have made the denominator 0. So that, for that reason, we have a hole in our graph right here at x equals 3. And that was removable. That's why our graph still looks continuous, because we were able to factor that out and remove that discontinuity. So that we do have a hole at x equals 3. So when I write my domain, I'm going to have x such that x cannot equal -2 or 3, and x, remember, is an element of the real numbers. So that concludes this tutorial. I'm going to have you try a question real quick. See how you can do on this one, determining the vertical and horizontal asymptotes and the holes of this function k of x. Thanks for watching, and we'll pick it up and finish the lesson.